Okay, so today we are continuing with our trig, and we're learning something called inverse trigonometry for T3. So, yay, something new. It's very similar to what we've been doing though, so don't worry too much. Okay, so our essential question today, how do you use trigonometry to find unknown angles in a right triangle? So remember in the past, we've been finding unknown sides. And today we're going to learn a new thing, how to find a missing angle rather than a side. So go ahead and jot down your initial thoughts there if you have any ideas. And if you don't, that's fine. It's like a technical thing to be able to do. So if you haven't ever done this before, it's totally makes sense. You would be like, I'm not sure. Yeah, I do see like that's a nice equation there. Yes, yes, yes. Good ideas, good initial thoughts. All right. Pretty much all not sure's and I don't know. Then that's absolutely fine. Okay. All right. So moving forward, here's your Desmos scientific calculator. So go ahead and click that link and make sure you have that ready for you on some other tab. If you're using a different calculator, that's fine. You don't need this, but this is the one I'm going to use today. Okay, I'm going to switch the slide in 3, 2, 1. You can also Google this. Okay, here we go. All right, so we're going to start with a little review, and I just want to get a feeling for where we're at with using trig to find side length. So this is exactly what we've been doing in all of our past assignments. So go ahead and try this problem, and then we'll check our answers in a moment. Okay, so I'm going to give you about a minute to try this problem out, and then we will regroup. Remember, when you're labeling the opposite, adjacent, and hypotenuse on your triangle, the hypotenuse is always opposite the right angle. It's the longest side. But remember the two sides that form the theta, the angle that we care about, the 37 degrees in this one. The two sides that form the angle are always the hypotenuse and the adjacent, which leaves this side over here as the opposite. Okay, so in order to choose sine, cosine, or tangent, we need to make sure that we're using the information that we have in our triangle effectively. So looking at the triangle, you can see how the opposite side, the opposite side is what we're trying to find. Change the colors. See how we're trying to find the opposite. So we're definitely going to use O for opposite. All right, that's in. We also already know this length, 10.3, which is the hypotenuse. So we're going to use opposite, we're going to use hypotenuse, which means adjacent is out. So when you look at SOHCAHTOA, anything with an A is out. Tangent and cosine are out. This leaves us with sine for this problem. And now we started the sine of the angle that we know, 37 degrees, is equal to the opposite side, which is x over hypotenuse 10.3. And then it's time to use your calculator to solve. Okay, so now we're going to go ahead and solve this. I need to plug sine 37 into the calculator, and you should get 0.6018. Remember to round to 4 places past the decimal when you're inside the problem, at least 4 places. And then equals 10x over 2.3. And then this is when I like to put my decimal over 1. And now it's time to cross multiply. So we multiply this way. X is equal to 0.6018 times 10.3, which is about 6.2. So if you got 6.2, we're on the right track. All right, so here we go. Now we're going to get into what we're learning today, what our actual learning is today. So now what about this situation? How do we find the measure of the missing angle? So notice in this triangle, we know a couple of sides. We know this side is 4, we know this side is 5. What we don't know is the angle theta. And this is what we're going to learn today. So it's just like a one extra step to find the missing angle rather than the side. So what we need a new mathematical tool to solve problems like these. Sine, cosine, and tangent aren't up to the task. They take angles and give side ratios, but we need functions that take side ratios and give angles. So what we need is a reverse operation, and this is called inverse trig functions. So instead of taking, like, for example, the sine of an angle we know and set it equal to our ratio to solve for an unknown side, we're going to take a known ratio and use inverse sine to find the angle that goes with them. All right, so here's the chart that sort of connects the original trig function, sine, cosine, and tangent, to their inverse functions and the new notation that we should be aware of. So notice this, we have sine of theta is opposite over hypotenuse. We knew that, that's SOH. So it's related to the idea of inverse sine, or sine to the -1 of the opposite over hypotenuse. So now we're taking the inverse sine of the ratio, and that will be equal to the angle itself. So, and this works the same way for inverse cosine, inverse tangent. So here's what this looks like in an example. Come on. Come on. All right, here we go. All right, so the example is done for you here, but I want to point out a few things. So first of all, the steps look very much the same as what we've been doing with trig in our previous lessons. Label the sides, opposite, adjacent, hypotenuse. That's in relation to the theta angle. Determine which trig ratio to use. And in this case, opposites not being useful. We know the adjacent, we know the hypotenuse, so we're using A and H together to use cosine. Write a proportion. So you can see this is like a typical proportion. Cosine of angle theta equals opposite or adjacent over hypotenuse, 4/5. But then that's where we detour. Solve using inverse trig functions. And this is when we rearrange our equation. So the angle by itself is actually equal to the inverse cosine of the fraction 4/5. So now the next thing we need to know is, how do we actually calculate that in our calculator? So I'm gonna, let's see, I'm gonna show you, I'm gonna pull up the calculator, so just give me a moment. All right, in order to find the inverse cosine of 4/5, so this is what we're going for. We want theta is equal to the inverse cosine of 4/5. We need to know how to punch that into our calculator. So notice on your regular screen on this calculator, we see sine, cosine, and tangent, but we don't see one with a -1. So there's a way to find it. So what we do is do you see how we're selected on main right now? What we're gonna do is switch over to func, which I believe stands for function. So click on func on your calculator. And look, now we have sine, inverse cosine, inverse tangent. It's all these ones with the -1s. So we can choose the one we need. So we go inverse cosine, and now we switch back over to main to get to our numbers. 4 divided by 5, and boom, there it is. We have our angle, which is 36.9-ish. degrees. Okay. So you just have to switch over to func, choose your inverse function, and then switch back to main to get the numbers. All right, so there's our 36.9 degrees, so how we use the calculator. Okay, so we'll go through another example, and then the next problems will be your chance to do some practice. Okay, so I'm gonna go ahead and start this process the same way we've been doing all along. We're going to label our sides. So there's our theta at angle A. So here's our hypotenuse and adjacent. Remember, hypotenuse and adjacent always form the angle that we care about, our theta angle, which leaves this side over here as the opposite. And then based on this, I can see that we know the opposite side. We know the adjacent side. We don't need the hypotenuse today in this problem. So opposite adjacent, that's O and A. That means we're going to use tangent, which relates the opposite to the adjacent. So I start by setting up my regular old tangent equation. Tangent of the angle, which we don't know now, it's theta, is equal to the opposite side, 4, over the adjacent side, 13. And now we need to switch to inverse trig. So I'm trying to get theta by itself because that's the goal, is to find the angle. So theta will be the inverse tangent of 4 over 13. So now we need to substitute this, or you need to plug this into the calculator. So we plug that in our calculator, and inverse tangent of 4 over 13 is 17.1 degrees. Okay. So I have one more example for you, and then the rest are going to be like practice problems, or like the next several problems are practice problems for you to try. So we'll do that after the quiz. So for this one, again, same process. We start by labeling the sides. So this is our hypotenuse, and our adjacent, hypotenuse and adjacent form the angle theta, and then opposite over here. And then based on what we have here, it looks like we know the hypotenuse, we know the opposite, so we don't want adjacent. So anything with an A is out, cosine is out, tangent is out, and that leaves us with sine, which relates the opposite, O, to the hypotenuse, H. So there's our sine. Start your equation. The sine of theta is equal to opposite over hypotenuse. Okay, now it's time to switch to inverse trig. Theta is equal to inverse sine of 10 over 12. And plug it into the calculator. So remember, you go from main over to func, click inverse sine, go back to main, and 10 divided by 12. You should get an angle of about 56.4 degrees. So here is an inverse trig application style problem. So we have an airplane that takes off 200 yards in front of a 60-foot building right here. At what angle of elevation must the plane take off in order to avoid crashing into the building? So that means we need to make sure it clears 60-foot building. So of course, you know, you would want to make it clear like by a little bit more than, you know, barely, but this would be like the absolute minimum for it to clear. So again, this is the same exact process we've been doing. We label our sides. So here is our hypotenuse. Here is our adjacent. The 60-foot side looks like our opposite now. And then we decide SOHCAHTOA. So I'm going to go ahead and write that out. SOHCAHTOA. Which one of those we want to use. So we look at our information that we know in our diagram, and it looks like we know the adjacent side is 200, so we're going to use adjacent. We know the opposite side is 60, so we're going to use opposite, and hypotenuse is out on this round, which means sine is out and cosine is out because they both use hypotenuse. So we're going to use tangent for this one. So now we set up our equation. The tangent of x, that's our unknown angle this time, is the opposite, 60, over the hypotenuse, 200. And then it's time to use our inverse trig. So now our angle that we're trying to find is equal to the inverse tangent, tan to the -1 of 60 over 200. And plug it into the calculator. Go over to my calculator, go to func, inverse tangent, back to main, 60 divided by 200. And that's approximately 16.7 yards. All right. So the next two problems on the slide deck are application problems that I would like you to do also as practice, okay? And then there is a slide that has the solutions for you that you can check your work on as well.